In this lecture, we will study the analog to digital converter and how this analog to digital converter is interfaced with the 8085. Now, if you see, this is the microprocessor 8085, and it will microprocessor always take the digital information and it will do some process and gives the digital output. Now, all naturally generated signals are analog signal. If we wanted to do some process on the analog signal, directly that analog signal can't be applied to the processor. Now, for that, what we need an IC which will convert the analog to the digital. Now, for this, what you have to apply the analog signal, and this analog to digital converter will convert this analog form to the digital, and these digital signals are applied to the microprocessor. And after the process, microprocessor will generate the digital information. Now, if you wanted to control the analog devices by using this digital, that you can't apply this digital signal directly to that analog device. Now for that, what again you need to convert this digital information into analog by using the DAC. Now for this purpose, converting analog to digital and digital to analog, we need ADC and DAC. And how these ICs are connected to the microprocessor is nothing but what interfacing the ADC and DAC. Now this already we have discussed. Now this is we are going to discuss. Now, what is ADC? ADC is nothing but what? This is an IC which where we are giving the analog input and it is converting this analog to the digital and giving the digital output. So now here we will see the successive approximation ADC converter, which we have already studied in the last semester in the digital electronics subject. Here the most important components are comparator, uh, DAC, and a successive approximation. Now, whichever the signal you wanted to convert it into the digital form, that signal you have to apply at this pin. Now, here you need to apply at this terminal analog voltage input. Now, here if I wanted to give the 9 volts, then this 9 volt is compared by using this comparator. Now it will compare what? Compared by the generated analog voltage. Now how this generated voltage will come means, now here we have a successive approximation register. It will generate the digital information. That digital information will be converted into analog by using the DAC. So that signal is compared with the analog voltage input. Now, if both the signals are matched, then whatever the digital information is generated by the successive approximation will be logged and that will be displayed by using this output register. Now, that digital information is nothing but an equivalent digital signal for this analog voltage. So, if it is not matched, now comparator will check that if it is matched or not matched. If it is matched, it will freeze that value. If it is not matched, so depending upon the value applied here, it is a low or high, so it will generate the signals, thereby what? Successive approximation register will change the digital information over here, and again the DAC will convert the digital to analog, and again it will check. Now this process will goes on until the analog input voltage and generated analog voltage should match. So this is about the successive approximation ADC converter. Now, like this, it will convert this analog information into digital information. Now, here we will see the interface. Now, this is nothing but what? IC. So, this is a 8-bit DAC IC. Now, in this IC, if you see the blocks, comparator, DAC, and SAR. Now, whatever we have studied here, comparator, DAC, and SAR. Now, apart from these three blocks, one more block is there, that is a tri-state buffer. And if you see this start is nothing but what? We are giving the start signal to this SAR to do the conversion, means what? Converting analog into digital form. So now this start signal should be applied, now given by the microprocessor. When the conversion is taking place, that time, now this data ready signal is disabled. Now this signal is low, thereby what? This tri-state buffer is not enabled. So what here the digital information, whatever the information we will get, that is nothing but what? High impedance, neither 0 not 1. So once the conversion is completed, so it will give the this data ready signal. This is nothing but what? This is nothing but a status of this IC, whether the conversion is completed or not. That can be known by using this data ready signal. Now, so processor will read this data ready signal. So processor will know that whether the conversion is completed or not. Once the data conversion is completed, so now nothing but what data conversion is completed means what this data ready signal is available. Now this will enable the tri-state buffer. Once the conversion is completed means what the digital information is available over here. So if the enable signal is applied to the tri-state buffer, so if the conversion is completed, the signal will be high, thereby what this tri-state buffer will is enabled, thereby tri-state buffer will transfer the data, whatever the data available here, onto the output, digital output. Just the tri-state buffer will transfer the data, it will not load the data, it will just transfer the data to the output. Now thereby what? Now here the data is available. So microprocessor will read the data. So now here how this complete IC is interfaced with the microprocessor, and how this microprocessor is giving the start signal, and how it is reading the status, and after the conversion is completed, by reading the status, microprocessor will know that whether the conversion is completed or not. Once the conversion is completed, and microprocessor is reading the digital information, that we are going to study under the interfacing an 8-bit ADC converter using the status check. Now here this data can be checked by using the two methods. Microprocessor will read the digital information by using the two methods. One is data check and status check, and another one is interrupt. So status check means what? Continuously microprocessor will poll the status of this IC. Once the conversion is completed, then processor will read the data. So interrupt means what? Processor continuously not check the data. Once the data conversion is completed, now the interface itself will send the interrupt signal to the microprocessor. Thereby microprocessor will read the data. Now in this lecture, I am explaining the interfacing an 8-bit ADC using the status check. So here microprocessor continuously will check the status of the DAC IC. If the conversion is completed, then processor will read the data. Now how that is happening? Now here if you see, this is the ADC IC, and this ADC IC here analog signal is applied, and it will give the digital output uh, after completing the conversion. Now for that what? Microprocessor will send the start signal over here. Now here if you see bubble is there means what? It will give the low signal over here, thereby what? It will start the IC, now conversion will start. Now when the conversion starts, at the time here the data bus, here the data bus is in the, it will go into the high impedance mode. So now after the conversion is started, now processor will read the status. How it will read the status? By reading the DR. DR is nothing but what? Data ready signal. So now whenever this data ready signal goes low means what? Conversion is completed. So now if you see here, this data ready signal is connected through this tri-state buffer onto the D0 bit. So now the processor will check the D0 bit. If this D0 bit is low means what? Conversion is completed. If this D0 bit is high means what? Conversion is not completed. So at the beginning, so before going to start the conversion, this complete bus is what? High impedance mode only. Now once the data conversion is started, now this DR bit is goes into high. So if the processor wanted to read the status, now it will send the low signal over here, thereby what? This tri-state buffer will be enabled, and thereby this high signal will be available on the D0 bit. If it is high signal is read by the processor, then what? High signal means what? Conversion is not completed. So processor will not read the data from this data bus. So now again after some time again it will read the status. Now, if the conversion is completed, the data is available, digital information is available on this at the output of the ADC, and also it will generate the low signal. Now, when the conversion is started, it will generate the high signal over here. Once the conversion is completed, it will generate the low signal over here. Once again, if the microprocessor is reading the status, then the low signal is available on the D naught. Means what? After reading the D naught signal, processor understands if the low signal is available on the D naught means what? Processor understands that conversion is completed. Thereby, it will generate the low signal over here. Now, this is nothing but what? Tri-state buffer to read the data. So once the processor generates a low signal over here, then whatever the data is at the ADC output is transferred onto the data bus. If once the data is available on the data bus, this data is loaded onto the accumulator. Now loading the data onto the accumulator is nothing but what? Processor is reading the data. Now you understood that how this conversion is taking place and how the processor is reading. Now for that, what the processor will do? Now to give the start signal, it will now this start signal is connected to where? It is connected to the port 82. Now here it is generating the three different signals: start signal, and for this tri-state enable signal, and here also tri-state buffer enable signal. So three signals are generated by the microprocessor. Now how these three signals are generated? Now if you see, this signal is connected to the port 82, this signal is connected to the port 81, and this signal is connected to the port 80. Now in this case, microprocessor is giving the start signal means what? Nothing but what? Processor is writing the signal. Now that is nothing but what? Out 82. When the microprocessor is executing this instruction means what? Out 82 means what? Immediately this 82 data is decoded by using this 3 to 8 decoder. 3 to 8 decoder means what? Inputs are 3 address bits and it will generate the 8 outputs. In that 8 outputs, it is taking only 3 outputs per this A to D converter, A to D converter interfacing. So now when after executing this out means what? It is giving the control signal as the right control signal, IO right bar signal, and port address is what? 82H. Whenever the 82H is given, it is decoded and it is generating the low signal on this port. Now the remaining port is not enabled, so the disabled. So only this port will be enabled. Thereby, it will generate the low signal over here. With this low signal, it is applied. The start signal is given to this DAC, says it ADC. Thereby, what? It will start the conversion. That time, a DR bit is at the beginning, conversion is started, DR bit is high. So now whether the conversion is completed or not, to read the status, so microprocessor will execute the in, and where the status signal is connected, which port? Port number 80. So in 80H, now after executing this in 80H, so processor will now here after decoding this data, now this port is enabled. Now here the low bit is generated and this port is enabled. In means what? A read control signal. So after giving the read control signal, now this port is enabled. Now it is generating the low signal over here. Thereby what? This tri-state buffer is enabled. Now whatever the DR signal is there, if the conversion is within the process, high signal will be available on the D naught. If the conversion is completed, low signal is available on the D naught. Now here once the enable signal is given over here, whatever the data is there on the DR, that will be available on the D naught. Thereby processor will read the D naught. If the high signal is there means what? Processor understands that processor is in between. If the low signal is available on the D naught means what? Processor understands that conversion is completed. Once the conversion is completed, then it will execute the, it will check. Now here the uh, in between we have it will check the status. If the status is low, then it will execute the in 81H. In 81H means what again? So this port will be enabled and it will be, how it will, in means what? Control signal is a right control signal, IO right control signal. 81H means what? This port. So 81 means what? Last signal is what? 001 means what? Output 1 will be enabled. Thereby what? It will generate the control enable signal over here. It will enable the tri-state buffer. Thereby what? Whatever the now conversion is completed means what? Data is available here. that data will be transferred to the data bus once the tri-state buffer is enabled. So after executing this instruction, so this data is available on the data bus. So once the data is available on the data bus means what? It will go and it will loaded the data onto the accumulator. Is nothing but what? Microprocessor is reading the digital information by using this instruction. And by using this instruction, what? Microprocessor is reading the status. Now this is the status. Now, by using this, what? Conversion is started. Conversion started. By using this instruction, what? Microprocessor is reading the digital data. Now, this is how the processor is reading the status, reading the digital information, and converting and started the conversion. And how these IC is connected to the processor. Now, this is about the interfacing the 8-bit DAC using the status check.